Hello guys, how are you doing? Now let's try this. We're jumping to 3D particle equilibrium. And I particularly think that this problem is out of sequence in the problems from the books because it looks very easy and I think it should be one of the problems that you use at the very end, not at the beginning. For the untrained people, untrained eye, they see this problem and they say, "Oh, this is so easy." Either this is so easy, or if you have a little bit more of training and understanding, and say, "Oh my God, I can't solve that problem." Let's see what happens. It says determine the magnitude of the force P and the orientation of this force for equilibrium. That's it. I mean, nothing else, nothing out of the ordinary here. However, when you start counting, let's see, this is particle equilibrium. Forces in the space concurrent at one point. You have three equations of equilibrium. Summation of forces in X must be zero. Summation of forces in Y must be zero. And summation of forces in Z must be zero. That means that the maximum number of unknowns that we can have are three as well. Well, how many unknowns do you have? You have P, 1, and then you have the direction for these force, which are alpha, beta, and gamma. So your unknowns are P, alpha, beta, and gamma. Three equations, four unknowns, but not really, because this is when the fourth equation comes into play. Remember, cosine square alpha plus cosine square beta plus cosine square gamma equals 1. In reality, you have four equations and four unknowns, and this is what you have to solve this problem. And how do you solve this problem, basically? So let's start. How are we going to solve this problem? In the same way that every type of problems that deals with particle equilibrium is solved. Express the forces in Cartesian, meaning ijk. Add the forces for equilibrium and solve for unknowns. But here we have to be a little bit creative in this particular problem. So how are we going to decompose these forces in Cartesian, etc., etc., etc.? Let's start with force 1. What do we have regarding force 1? Well, regarding force 1, we have basically magnitude and we have coordinates. What the problem is telling you is basically in order to express the force 1 as a vector, you need the magnitude, yes, and then you need the unit vector from this force. And the unit vector of the force 1 can be obtained by stating a position vector for force 1 divided by the magnitude of the position vector for force 1. Luckily for us, everything can be done here. So the force 1 will be magnitude of the force 1, 360. Position vector, these coordinates minus these, which are 0, 0, 0. So basically, that will be negative I, negative 7j plus 4k divided by the magnitude of that position vector, 1 squared plus 7 squared plus 4 squared. And that will give us the force 1 as Cartesian. I'm going to copy it here. That will be negative 44.313I minus 310.191J plus 177.252K. Force 1, perfect. Force 2, awesome. Why I say awesome? Because the magnitude is 120 and goes in the negative direction of J. So force 2 basically is going to be negative 120J. And I'm putting it spaced like that because at the end I would like for all I, J, and K to come together and I don't miss anyone when I work it out. Force 3 is this force? This is when, things start getting a little bit crazy, but let's try to do it. So force 3 is going to be equal to 300 cosine alpha I plus 300 cosine theta j plus 300 cosine gamma k, because I don't know the direction, so I have to express it like that. And I say 300, 300, 300, and nobody corrected me. Look, it's 200. What are you doing, guys? Why don't you correct me? Don't believe everything that I tell you. Okay, now we have that over there. Force 3. For force 4, amazing. Why is amazing? Because it goes in the negative direction of the z-axis. So it's going to be 0, 0, negative 300k in this way. And now we are missing the force P as Cartesian. And as Cartesian, the force P don't have any component in x because it goes entirely in the YZ plane. So this component and this component will be P cosine 20 in the J direction. So cosine of 20, that would be 0.9397 PJ, plus the K component, which is positive as well, and it's going to be sine 20 multiplied by P, 0.342 K, PK. Okay. Once we have this, we can start working out our problem. And when I say start working out, I really mean start working out. So let's see what happens here. Let's add everything that we add here has to be 0, 0, and 0 if it's in equilibrium. So let's start with the i's, this part. That corresponds to summation of forces in x equals 0. What do we get in I? We get negative 44.313, this one, plus 200 cosine alpha, and there's nothing else, equals 0. So that means that from here I can solve for cosine alpha, which will be 44.313 divided by 200. Parenthesis is not supposed to be here. So 0.22 1565, which means that alpha is going to be the inverse cosine of that, and that will be 77.2 degrees. That's easy. Now let's go with the next equation. Summation of forces in y equals 0. Then we start here. We have negative 310 310.191 minus 120 plus 200 cosine beta plus 0.9397 p equals 0. So let's combine these numbers, and basically this will be, something, I know what is going to happen, so let's try to do it at once. Let's solve for cosine beta in this equation. Will be this. This plus this is negative, is going to pass to the other side as positive, and the value will be 430.191. Remember, these two added to the other side, minus, when I pass this to the other side, minus 0.9397p divided by 200. That's what I can get combining or by doing summation of forces in J. So far, I have one result and I have one equation here. Let's keep moving. Now, what do we do now? We do summation of forces in Z, which is the K here. If I add this one, this column, you will get 177.252 plus 200 cosine gamma minus 300 plus 0.342p equal 0. And now we can solve, we can combine these things here. And this is going to be 177.252 minus 300, 177.252, 122.48 when I pass it to the other side, 122.48. So I'm going to solve for cosine gamma here. It will be 122.748. Remember, that comes from this and that. It's going to be negative. Pass it to the other side. Positive. This is going to be minus 0.342p divided by 200. That will be cosine gamma. And I have a second equation here. And now we use our other equation, the equation that relates alpha, beta, and gamma. So basically what we do is cosine square alpha plus cosine square beta plus cosine square gamma equals 1. We have cosine alpha, so that will be 0.221565 square plus this number square. I don't know how much is that, and I really don't care too much how much is that. 0.221565, 0.22. I don't want to mess up because after working all this time, if I mess up here, it's going to be a pain. Cosine square beta will be 122.748 minus 0.342p divided by 200, and this is going to be a square. I'm going to put another parenthesis here to make easier when I plug that into the calculator. Now plus cosine square gamma. Oh, I wrote it out of this is cosine square gamma. So I'm gonna put cosine square beta. See 400. You see, this shows you that I'm doing this live and not reproducing any paper or any problem. I didn't solve it before. 97p divided by 200 square equals 0. Now, how do we solve this problem? How do you think we've solved this problem? This problem, I mean, it takes time. It's solvable. You can elevate this to the square, combine the p's, square the p's, apply a square root, and solve it. Or you can use the whole equation as is and use trial and error. And this is what I'm going to do, trial and error. You don't need to. Remember, square of this one plus minus 2 times this square, combine all the numbers, fill a complete page on that. I honestly rather working with trial and error. And trial and error, the only thing that you have to be really careful is whenever you plug this into the calculator. So the first one is 0.221565 square plus parentheses, and then I'm gonna put this other thing that we have here, which is 122.748 minus 0.342 times, I'm gonna give an initial value for P of 500. Why 500? Because of the forces involved into the problem. It looks a good first guessing. I might be wrong, but it doesn't matter. Let's start with 500 and then we are correcting it. So I'm going to put here 500. that will be that P over there, divided by 200, and now everything is square in this term, square. Now go to the other term, which is this term here, plus parentheses, 430.191 minus 0.9397 times, we say 500, that's initial value for P, divided by 200, and this is going to be a square. And now we just hit enter. And we get for 500, so for 500 we got 0.146, and we should get 1. Because remember, cosine square alpha plus cosine square beta plus cosine square gamma equals 1. But we're close. So let's try for P equals, I don't know, 650, and see what value we get. Let me see if it's still stored here in the calculator. I don't know if I still have it. Oh no. I'm gonna have, yeah, the calculator turned off, so I'm gonna have to code everything again, which I didn't want to, but 0.221, maybe it's a good practice for you guys as well. 221565 squared plus parentheses 122.748 minus 0.342 divided by 200 plus parentheses square plus parentheses, but I didn't put the value. Oh, I'm so smart. 342p, and we say that we will, let me try again with the 500 because I want to be sure that the values are correct, times 500 divided by 200 square plus parentheses 430.191 minus 0.9397 times 500. I open two parentheses. This is critical. If you don't get it right, the code is 2 parentheses times 500 divided by 200 square, and we got 0.416. Yeah, 417 actually, but it's okay. 416. Now we say we're gonna try again with 650 because you know it has to be 1. Probably the force has to be bigger. So I'm gonna try here with 650, and the other one that we have to change in the beginning is 650 as well. Here, yeah, 650, and then we get 1.1. That means that if we're looking for 1, it's between these two. So let's try for P equals now, and it's closer to this one, really close to this one. Let's say 640. 640. Go up, enter, change 650 for 640. Change 650 for 640. Here, hit enter. 1.01. I don't know about you, but I can live with this because I should get 1 and I got 1.01. You can keep reducing it, but it doesn't worth it. 640 will be the value for P. So P equals 640 Newton. Is Newton? Pounds. And alpha, we already know alpha. We were working with that before. Alpha is 77.2 degrees. Now if I want to know the rest, I know the cosine gamma is 122.748 minus 0.342 times the force, 640, divided by 200. So that will be 122.748 minus 0.342 times 640 divided by 200, and then you get the inverse cosine. I hope this is correct, otherwise I'm gonna check it anyway, so don't worry. 0.481, and inverse cosine of that will be 118, 118.73 degrees, 118.73 degrees, and then we need also cosine beta. Cosine beta was in this page here. Cosine beta equals 430.191 minus 0.9397 times 640, because that's the value for P, divided by 200, and that will be, let's see, 430.191 minus 0.9397 times 640 divided by 200. This value will be negative 0.856, which means that beta will be the inverse cosine of that, 148.88 degrees. Now, if you just want to be sure at the end that your alpha, beta, and gamma are correct, which for that force, which they should be, but you never know, you can always go back to cosine squared alpha plus cosine squared beta plus cosine squared gamma. It has to be equal to 1. So let's try that. Cosine squared alpha, 77.2, plus cosine squared beta, 148.88, plus cosine squared gamma, 118.73, and that has to be equal to 1. Ta-da-ta-ta! Drum rolls. Let's see. That's why I'm not a drummer. My son is in a band. And how can you find my son? Well, he has my name, so you can look for him. Cosine square. Let's start with that. Parentheses. Cosine 77.2 square plus parentheses cosine 148.88 square plus parentheses cosine 118.73 square. Ta-da-da-da. 1.01. Yes. Yo, good. You see, once again, this is not the typical first problem in the series of problems, but I wanted to bring it to you because you just look at it and it looks like it's easy, and it's not complicated, but it demands a lot of work in order to solve the system of equations. Keep watching, guys. I'm gonna try to keep more interesting problems like this one. Have a good day.